Hello, we are from Group 2.
Ini Dimas Aditia.
I'm Rizki Maulana.
I'm Faiha Qathrunnada.
I'm Tabina Phalosa. In this video, we will learn about some fundamental mathematical concepts, starting from type of numbers,
LCM and DCF.
Then square, square root, cube, and cube root.
And lastly, exponent and logarithm.
Okay, the first material is type of numbers. Numbers are the most basic elements in mathematics that we use in calculations in our daily lives. So, do you know there are various types of numbers in mathematics? The first one is natural numbers. Natural numbers is any positive integer numbers that starting from 1, 2, 3, and so on until infinity. Okay. The second one is whole numbers. Similar to natural numbers, whole numbers are any positive integer numbers including 0. So, whole numbers start from 0, 1, 2, 3, and so on until infinity. The third one, integer numbers. Integer numbers are any whole numbers that can be positive, negative, or 0. For examples, negative 2, negative 1, 0, 1, 2, negative infinity, positive infinity, and so on. From integer numbers, it can be divided into two other types of numbers, which is the first one is odd numbers, and the second one is even numbers. Odd numbers are any integers that cannot be divided by 2 without a remainder. For examples, there are 3, 5, 7, 9, and so on. Even numbers are any integers that is exactly divisible by 2. For examples, there are 2, 4, 6, 8, and so on. Okay, the fourth one is prime numbers. Prime numbers are whole numbers greater than 1 that has only 2 factors, which is 1 and the number itself. For examples, 3, because its only factor are only 1 and 3. Second example, 5, because its only factors are 1 and 5. The third example, 7, because its only factors are 1 and 7, etc. Okay, the fifth one is rational numbers. Rational numbers are numbers that can be written in a fractional form of two integers, like a divided by b, where b is not equal to 0, where the decimal form is terminates or repeat. For examples, 6 divided by 3 equals 2. The next example, 12 divided by 99 equals to 0.12. The third example, 5 divided by 10 equals 0.5. Okay, the sixth one is irrational numbers. Irrational numbers are numbers that cannot be written in a fractional form of two integers, and the decimal form do not terminate or repeat. For examples, square root of 2, then Euler numbers, and p. Okay, next, from the two various types of numbers, rational and irrational numbers, we can combine them into the category of real numbers. Like the definition, real numbers are union of rational and irrational numbers. So, for the examples, there are 2 square root of 2, 3.14, and so on. Then negative 5, 0.5, and etc. Next, the eighth one is imaginary numbers. Imaginary numbers are numbers that can be written in the form of bi, where b is a real number and I is imaginary unit, where I equals square root of negative 1 or I squared equals to negative 1. For example, we have square root of negative 4 is equal to square root of negative 1 times 4 equal square root of negative 1 times square root of 1. And as we know before, square root of negative 1 is I. Negative times square root of 4 is 2. So the answer is I. Okay, the last one, we have complex numbers. Complex numbers are the sum of a real number and an imaginary number that can be written in the form of A plus BI, where A and B are real numbers and I is imaginary. Okay, for example, we have 3 minus 2i times 2 plus 4i equals 6 plus 12i minus 4i minus 8i squared equals 6 plus 8i minus 8i squared equals 6 plus 8i minus 8 times, as we know before, I squared is equals to minus 1. So we can write it here. So next equals 6 plus 8i plus 8. And the result is 14 plus 8i.
Now, let's move on to the second material, which is LCM and CCF. LCM stands for least common multiple, which is the smallest number that two or more numbers share as a multiple. We usually use LCM to find when two parties because will happen together. Meanwhile, CCF stands for real number factor. CCF is the biggest number that can divide two or more numbers equally. We use CCF when we want to define object or equal group with nothing left over. For example, let's look at the case of Dimas and Rizki. Dimas visit the library every 2 days. Meanwhile, Rizki visit the library every 3 days. On Monday, they meet at the library. They want to know, when will they meet again at the library? To find the answer, we need the LCM of 2 and 3. LCM 2 and 3. Okay, the LCM will use the smallest interval when both schedule meet again. First, make a list of their multiples. Multiples of 2. Multiples of 2 is 2, 4, 6, 8, and so on. Multiples of 3, 3, 6, 9, and so on. Okay, now find the number that appears in both lists. Nah, the same numbernya is 6. So, the LCM is 6. So, Dimas and Rizki will meet again at the library 6 days later, exactly on Sunday. They will meet again at the library. Okay, for the GCF case, we can take the group division example. Situation, Class B has 8 male students and 36 female students. Discussion groups will be made with the same gender composition is age group. The number of groups should be as possible. And most students are without. For the solution, let's first read down the factor of 8 and 36. Okay, factor of 8. For x, 1 times 8, 2 times 4. So, factor I of I is 1, 2, 4, and 8. Next, factor of 36 is 1 times 36 and 2 times 18, 3 times 12, and 4 times 9, and then 9 times, and 6 times 6. So, the factor of 26 is 1, 2, 3, 4, 6, 9, 12, 18, and 26. Okay. No. The DCF of I and 26 is 4. So the solution we get is that we can from for group is group will have 12 students, 12 students, I divided by 4 is 2 students. Okay. The next female students, student 36 divided by 4 is 9 students. Okay, so in terms of that understanding, the concept of LCM and CCF help you find solution in everyday life, guys.
Next, we learn about square and square root. Have you seen the number with this symbol? It means it's a square number. And what is square number means? It means the number multiplied by itself 2 times. So if we got the 4 squares, it means 4 times 4 equal 16. And then for the square root, if you have seen this symbol, it's a root, and it means what the number times 2 times multiply 2 times, it equal 64. So the number is 8. 8 times 8 is 64. So the square root of 64 is 8. And then we move to cube and cube root. Have you seen about this symbol in the number? It means the number is cube. And then what is the cube number means? It means the number multiplied by itself 3 times. If we have 5 cube, it means 5 times 5 equal 125. And then what about cube root? Cube root is uh like a square root but have the 3 in the left of the root. Okay. What is the cube root mean? It means what the number time by itself 3 times equal the number of cube roots. In this example, we have 8. What the number times by itself 3 times, it's equal of 8. It's a number 2. 2 times 2 times 2, it's 8. And we got the cube root of 8 is 2. Okay, next, we learn how to solve the big number in keywords. Okay, for the first example is 5,832. So, how to we solve this big number? So, the solution is first we must remember units of cube. Resolve the cube of 0 until 9, and then after we remember the units, the second step is we must spread the three numbers from behind 1, 2, and 3, and then we spread it. Okay, and then we look the unit of this cube root is 2, and then we look the result of cube from 0 until 9 that have the unit of 2, and then for the example it's 8, and then for the number we must look the result of cube 0 until 9. So in this example is 5. So we must look the result of cube 0 until 9 that have result equal 5 or less than 5. And that means it's 1. Because if the cube is 8 and it's more than 5. So the result of cube root from 580 5,832 is 18. Okay, for the second example, we have 74,088. So we next we solve this example. First, we separate the three number from the line, and then see the unit of these three number. And the unit of these three number is 8. So we look the result of cube 0 to 9 that have units 8 is 2. So the unit of this cube root is 2. And then we must, and for the other part, we must search the closest result of 0 until 9 is equal 74 or closest 74. And for this example, we got 4. Because for the closest, the result of 4 cube is closest to 74. Okay, for the last example, we have 117,649. And then we must separate the three numbers from behind 1, 2, and 3. And then we look the unit of these three numbers is 9. And then so the unit of this cube root is 9 because the 9 cube have units 9 in the units. And then for the other number, we must look the result of 0 until 9 that closest to 117 or equal 117. And then for this example, it means 4. Because if we have 5, it's more than 117, or if and the 4 is the closest to 117. So the cube root of 117 and 649 is 49.
Now I will explain about exponent. What is exponent? Exponent is the repeated multiplication of number. This general form of exponent, a to the power n equals a times a times a times a as much n times a for base and n for exponent, where a is real number and n is real number 2. I will show you the example of exponent. The example 3 to the power n equals 3 times 3 times 3 times 3 equals 27. These are properties of exponent. You can see it by itself. Okay, example, we have 2 to the power 4 times 2 to the power 3 divided by 2 to the power 2. To solve this problem, we can combine of the first and the second properties of exponent. Then will be then equals 2 to the power 4 plus 3 minus 2 equals 2 to the power 5, and the result is 52. In another properties of exponent, we have a to the power 0 equals 1, always 1. Why? I will prove this. I will show you about, for example, 2 to the power 2 divided by 2 to the power 2 equals 2 to the power 2 minus 2 equals 2 to the power 0, right? So, 2 to the power 0 equals 1. Why? Because 2 minus 2 is 0. 2 to the power 0 equals 1. Another solution, 2, I will write this. Another solution, 2 to the power 2 is 4, and 2 to the power 2 is 4. 4 divided 4 equals 1. So, let's do it. Previously, we discussed about exponent. Now we come to logarithm. What is logarithm? Logarithm is the inverse of an exponent which used to determine the power of base number. We know in exponent a to the power n equal x. In logarithms, we call log base x of a is m. A for base with a greater than 0 and a is not equals 0. X for numerals with x greater than 0 and n for exponent. For example, we have 2 to the power 3 equals 4. Then will be then will be log base 8 of 2 is 2. These are properties of logarithms. You can see it by itself. I will show you two examples of progressive logarithm. The first number is we have log base 27 divided by 3 of 3 equals, it's same like log base 9 of 3, right? So, so the result is log base 27 of 3 minus log base 3 of base 3 of 3 equals 3 equals 1. 3 minus 1 is 2. Now we prove it. Log base 9 of 3 equals 7. Next, the number 2 of example, we have log base 2 to the power 2 of 2. It's same like log base 4 of 2, right? So, we got 2 from base is left 2 times log base 2 of 2 equals 2. Log base 2 of 2 is 1. So, we have 2. Okay. Log base 4 of 2 is, let's go with. Well, that's all the material we have prepared for today.
We hope our video helps you to understand the fundamental math concept more enjoyable and more easily.
Thank you for watching, and don't forget to keep practicing.
Because the more you practice, the better you get. See you at the next learning session. Bye!